Hi everyone. For what values of x does our series converge absolutely or conditionally? We're also going to find the interval of convergence. We're going to use the ratio test, and we're looking at the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So I know this is hard to see, so if our limit is less than 1, then it's absolutely convergent and therefore convergent. If it's greater than 1, it's divergent. If it equals 1, it's inconclusive, and that means you have to do a different kind of test on that. So that's where we're going with this. So we're going to write this is going to be your a sub n. So filling out our limit, we're going to use the limit as n approaches infinity. And for substitution, we're going to get 4x minus 5. And we're doing this n plus 1. So it's going to be 2n plus 3 divided by n plus 1 to the power 3/2. And then we're dividing by a sub n, which is the same as multiplying by the reciprocal. So that's going to be times n to the power 3/2 divided by absolute value of 4x minus 5. Now, let's just look at this real quick. This is 2n plus 1. If you look at this, if you have a to the power of 2n plus 3 divided by a to the power of 2n plus 1, that means you have the same base. This is a to the power of 2n plus 3 minus 2n plus 1. This is going to give you a squared. So basically for this piece, I'm going to pull it out and write this as absolute value of 4x minus 5 squared times the limit, and these are both to the power of 3/2, so I can write this as n divided by n plus 1 to the power of 3/2. Okay, when you evaluate this limit, this just equals 1. So basically this equals absolute value of 4x minus 5 squared. So basically the series converges absolutely for absolute value of 4x minus 5 is less than 1. And if you solve for this, this would be 4x minus 5 is less than 1 but greater than negative 1. So if you add 5 to both sides, you're going to get 4 is less than 4x is less than 6, and then divide both sides by 4. You're going to get 1 is less than x is less than 3/2. So we know that x belongs in the interval 1 to 3/2. Okay, also our series diverges for absolute value of 4x minus 5 is greater than 1. But what we need to check now is our endpoints, 1 and we had 3/2, and see what happens there. So we're going to check for, so this is diverges. If we have x equals 1, then we're going to get the sum from n equals 1 to infinity of negative 1 to the power of 2n plus 1. I'm just using substitution, and n to the power of 3/2. Now this equals negative sum of n equals 1 to infinity of 1 divided by n to the power of 3/2. Well, according to that, we're testing at 1 here. Our p equals 3/2, which is greater than 1. So it's convergent absolutely by the p series. All right, let's also check for x equals 3/2. So if you do that, you're going to get the sum from n equals 1 to infinity of 1 to the power of 2n plus 1 divided by n to the power of 3/2. This is going to equal the sum from n equals 1 to infinity of 1 divided by n to the power of 3 halves, which again converges by the p series because 3 halves is greater than 1. So it's convergent. So since that's true, we have our interval of convergence at our endpoints is going to be a closed interval 1, 3 halves. The series converges absolutely on also 1, 3 halves. And there is no conditional convergence. And that's it. Thank you. Have a nice day. Bye-bye.